My name is Matthew Byron,
And I'm Kalen Ryber.
and we're doing number 12 for you on your Utexas.
For work and energy. For work and energy.
Okay, so at first this seems like a pretty difficult equation, but, or problem. But what you need to do is you need to just go through and set up the equation as you see it. So the equation you need is right down here. So if you fill that in, you have the peak right up here, where they have the most potential energy because they aren't moving and they're at the highest height. So that's 1.8. So potential energy equals 1.8 multiplied
This isn't gonna work. You're doing it the wrong way.
multiplied by mass multiplied by gravity, which is 9.8 meters per second squared, the acceleration. Right now, just ignore the mass because it will take care of itself later. Now, we also need to find the kinetic energy of the bottom, which is 0.5 meters off the ground. Now, to find the
No,
kinetic...
you need the KE at the top first.
What?
You need to find KE at the top and tell them it's 0.
Okay. Well, first we gotta find the kinetic energy at the top. Now, since they aren't moving, it equals 0. So kinetic energy equals 0. Equals 0. This is because they have no velocity, and so it cancels out the mass and the 1/2. Okay, so this is the top. T O P. I will cross it. Okay, now we're gonna change colors for the bottom section. How about red?
I like red.
Okay. So, bottom section. We'll just call it bot. Okay, now we have to find the potential energy, which is... Yeah. We have to find the potential energy. Now, at first it would seem like the height would be 0.5 and you would have potential energy. The thing is though, since you're connected to this line, which is 4.4 meters, you are cresting at the bottom there, and so you're not actually falling. You have basically 0 height.
You have height. Height is 0.5.
Either way, you won't have any potential energy.
Yes, you will. Because your potential energy is 0.5. All right. So, unlike Matt was saying, there is potential energy at the bottom. So, at the bottom, potential energy equals mass, which, again, doesn't matter yet, and you'll see why in a sec, times, you guys do that, times acceleration due to gravity, which is 9.8, times the height, which, as you can see over here, is 0.5 meter.
Start menu and go to Smart Recorder.
Now at the bottom, there is a kinetic energy, and the kinetic energy equals 1/2 times the mass, which we don't know, and the velocity, which is what we're trying to find out, and the velocity squared. Now that we have all these numbers, what do you do with them? Well, we plug them into this equation over here. Oh, I can't draw a circle. All right, so that is potential energy plus kinetic energy at the top equals potential energy plus kinetic energy at the bottom. All right, so let me take my handy-dandy eraser. And hopefully we have those written down, because we're going to plug them into one giant equation, which I shall write in green. Now, the top potential energy at the top equaled 1.8 times the mass times 9.8 plus 0 because there was no kinetic energy at the top. And that equals the potential energy at the bottom, which is 0.5 meters times the mass times 9.8 plus the kinetic energy at the bottom, which is 1/2 mass velocity times the velocity squared. Now, if you'll notice, both sides contain an m, and every part of both sides contains an m. So we can cancel out the mass, and this is why you do not need the mass of the girl on the swing. Now what you're trying to solve for is the velocity at the bottom. So we're going to move all of this stuff around so we can solve for this v here. So on this side, you will end up with 1.8 times 9.8. That's an x. I apologize. Minus 0.5 times 9.8, which moves this over here. And next we need to get rid of this 1/2. And to do that, we will multiply the whole thing by 2, and that will give us v squared. And we got v squared to equal 27.44. And to get the final velocity, you take the square root, and you get v to equal 5.24. And you've now solved the question. This is question 12 on the Utexas for work and energy. Thank you.